Welcome once again to another portfolio theory video. I would like now to talk about determining the circumstance when the feasible set in the two-stock case will, quote, bend backwards and effectively exhibit a negative slope as you begin adding some of the riskier asset to the low-risk asset. We already know that this condition, correlation coefficient between x and y being less than the standard deviation of x divided by the standard deviation of y, is necessary for the feasible set to bend backwards, and that is what we want to show here. So we start off by saying the variance of the return of a portfolio of two securities is equal to the weight in x is just 1 minus w squared times the variance of x's returns, plus the weight in y, which is w squared times the variance of y's returns, plus 2 times w times 1 minus w times the covariance of the returns of x and y. We next take the first derivative of the portfolio return variance with respect to w, the weight in y. Okay, and we use the chain rule. As you can see, this 2 comes down here, 2 times 1 minus w to the first power. Then you have to go inside the parentheses and differentiate what's in there with respect to w, and of course you get the minus 1, and then the sigma square x is carried along as if it is a constant. And then the second term, w squared, becomes 2w, and the sigma square y is carried along as if it was a constant. And over here we have the product rule, so it's 2 times the covar xy times w times the derivative of 1 minus w with respect to w, or minus 1, plus the derivative of w, which is 1, times 1 minus w. You get this. And then we just organize terms a bit, and we are left with this. Now we're going to evaluate the derivative at the point where w equals 0. Since w equals the weight in y, when w equals 0, this means we're starting at x, having therefore all of our wealth in the low-risk, low-return asset. So when we plug a 0 in for w up here, we're left with this equation here. Again, plugging in 0 for w up here leaves us with this equation. And then we make an observation that the curve bending backwards with respect to change in w implies that the derivative of portfolio return variance for a two-stock portfolio with respect to change in w is less than 0. It has to be negative, bending backwards, exhibiting a negative slope. And therefore we simply take this term here and make it less than 0. So we're just effectively moving them to the other side of the equation. We're just effectively flipping the terms around here and making them less than 0. And here in this step we divide by 2. We observe covar xy has to be less than the variance of x. And then going from this step to this step, we're putting in the correlation coefficient definition of covariance. So this, of course, is equal to covar, and that's less than variance of x, and therefore the correlation coefficient between x and y has to be less than this. Here we have canceling, and therefore we see our final result. The correlation coefficient between x and y is less than the ratio of standard deviation of x's returns to standard deviation of y's returns, and that is the condition necessary for the feasible set to bend backwards, that is, to exhibit a negative slope initially as you begin to add the riskier, higher return y to the lower risk, lower return x. And that's our first proof. The second proof we have involves finding the 0 variance portfolio when the correlation coefficient equals -1. Okay, finding the zero variance or zero standard deviation portfolio when the correlation coefficient between the returns of x and y, again in the two-stock case, equals -1. So here we have the variance of return for a portfolio of two securities is equal to 1 minus w squared times the variance of x plus w squared times the variance of y plus 2 times w times 1 minus w times the covar of x and y. And what we're doing in the next step is we're just plugging in this term for covar as before. And then we note that by assumption for this analysis, the correlation coefficient between the returns of x and y is -1, so we plug a -1 for this value here. And that just changes this sign to this plus sign to a minus sign down here. And then we just kind of rewrite what we have up here, plugging in the -1. And then we observe that this sequence of terms can be factored into this. 1 minus w times the standard deviation of x minus w times the standard deviation of y squared. And then we're trying to find the zero variance portfolio, so we set the variance of the portfolio's return equal to 0. And so we want this to be equal to 0. So 0 equals this. And first thing we do is take the square root of both sides. The square root of 0 is still 0. Square root of this is this. And we have 0 equals standard deviation of x minus w times the standard deviation of x minus w times standard deviation of y. We bring the terms that have w to the left-hand side of the equation in this step. Then we factor out a w. And then we divide both sides by the sum of sigma x and sigma y. And lo and behold, w equals sigma x over sigma x plus sigma y is our answer. What's that mean? Well, w is the weight in y. And so if this is the weight in y, then a portfolio that has a correlation coefficient between the returns of x and y of -1 will have a 0 variance and, of course, a 0 standard deviation. Now, for our third and final proof on this video, we want to simply find the minimum variance portfolio or the minimum standard deviation portfolio. No restriction on the value of the correlation coefficient between the returns of x and y. So again, we start off with a decomposition of portfolio return variance formula. There's, again, the variance of returns for a portfolio of two securities equals this familiar term. And then we take the derivative of the portfolio return variance with respect to w. And you can see that. And we just kind of tidy it up here in this step. And then we want and this is the variance, so we want it to be 0. So we say 0 equals this. And then it's just a matter of algebraically solving. You can follow the steps down here. Again, you want to get the terms with a w in to the left-hand side, because then you can factor out the w and get to your nice, neat answer, which is right here. If the weight in y is equal to this, then you will have identified the minimum variance portfolio. Of course, the weight in x would be 1 minus this value. And then we note that the second derivative of portfolio return variance with respect to the weight in y is positive, and that is just shown to you to reveal that we indeed have identified a minimum and not a maximum. And that's the end of this video. Thanks for watching.